Hey guys, and welcome to Physics 101. Today, the topic we are going to cover is friction. Friction comes in two forms, static friction and dynamic friction. So we're going to start just by reading these descriptions over here. We have static friction is a force that keeps an object at rest. It must be overcome in order to start moving the object. And when this force is overcome, then we see the dynamic or kinetic friction, which is friction when an object on a surface is in motion. Right, so we know the two different types here. Static friction, which is when an object on a surface is not moving, it'll experience static friction. When it is moving, it becomes dynamic or kinetic friction. And here we have a little more a continuation of static friction. If a small amount of force is applied to an object at rest, the static friction has an equal magnitude in the opposite direction. If the force is increased, the value of maximum static friction will eventually be reached, and then the object will start to move. So that should give you just a small idea on how when an object is at rest, it's on a surface, we talk about static friction. But then when it starts moving, we talk about dynamic friction. We have the formulas over here for this topic. We already know force equals mass times acceleration. But then we have these two here. We have the force of friction is less than or equal to the coefficient of static friction times r, which is the normal force. And then here, this is the formula for a dynamic slash kinetic friction, and it's pretty much the same thing. Frictional force equals the coefficient of dynamic friction times the normal force. Okay, so I'd just like to put a pin in that, and I'd like to go now into a diagram of a block or brick, whatever, on an inclined plane, because this format is what you'll see a lot in questions on an exam or in a textbook. So we'll start with just an inclined plane. Okay, so this is just a little ramp here. And then we have the brick, or whatever. Oh, shoot. An object. We'll just say an object. Ugh. Okay, that's terrible, but actually I'm going to neaten it up. Last go. Here we go. Okay, much better. An object here, and here's the center of mass. So when, let's say it's not moving, okay, so it's not sliding down the plane, it's just sitting there. It's going to be experiencing static friction. The forces, what are the forces acting on this object? So we know straight away there's a weight force. Call that W, weight force, which is going to be mg, but we'll get to that in a sec. And then we know there's a normal force. Now we know the normal force, or the reaction force, is meant to be equal but in the opposite direction. Equal in magnitude, but in the opposite direction. Now, normal force has to be perpendicular to its surface. So if you're thinking of just doing it like this, it's incorrect. It has to be perpendicular to the surface that it's on. So it's actually going to be this way. Okay, and then we're going to label it n. Right, and these two should be equal in length. I don't have enough space here, but they should be equal in length. And then we're going to have a frictional force. And no surface is frictionless. So we're going to have a force here, F. We're going to call it F of F, frictional force, in that direction. Right, so these are the forces. Now, let's say this angle here. Now this angle here, angle of incline, is going to affect a lot of our variables here, a lot of components to this example. So a lot of times what you'll be asked is what is the magnitude of the weight force, or what is the magnitude of the normal force, or what is the magnitude of the frictional force. You'll be asked to find a lot of these variables. So let's start with the first step in reaching that goal of being able to find the variables. Is what I'm going to do first is kind of just visualize, add parts that aren't really there, but we can assume, right? So let's say the normal force is this direction. Let's just make another line here, right? And say, well, this is the same thing, right? It's parallel, it's the same length. Let's just say the normal force was this direction. And then, well, we can kind of see here, we've got a little bit of a triangle going. Now this segment right here is also going to be equal to the force of friction, right? So this part of the triangle is going to be the normal force, and this part of the triangle is going to be the force of friction. And this is all imaginary, but we can do this because we know what N is, and we know what the force of friction is, and it's pretty much the same thing as doing this. We could also just do this and call this W. Oh my goodness. Call this W from there to there. But anyway, once we do that, this angle here, in here, is going to be the angle that's in here. Now this is just geometry. It's a little bit, can be a little bit complicated if you're not too familiar with how to do trigonometry, such as cosine, sine, and tan. So you might want to become familiar before we go into the next part. But yeah, just you'd want to practice it a bit. So now that we have this, now we have kind of this mapped out nicely. Let's say if it was asking you for the force of friction, what is the magnitude of the force of friction? All right, well, we can find that. Remember this arrow here, we're equivalating that to this side of the triangle. And so if we have our angle here, let's see. Well, we're always going to know, assuming we know what the mass of the object is. Let's say the mass is, in this case, is 10 kilograms. If we know that, we're going to use this part, the weight force of the block, for finding the rest of our variables. This is the key. Knowing, if you know what the mass is, we know A or G, or the acceleration, is going to be 9.81. Right? So, okay, so let's get back to finding the force of friction. Well, we want to find this, so we need opposite, and we also need the hypotenuse. So the hypotenuse is W. So let's rewrite this here. So opposite and hypotenuse, that's going to be sine. So sine, a lot of times you'll be given the angle, but we're just going to label it as theta for now, equals opposite, which is that. So we'll just write force of friction over hypotenuse, which is W. Now W, we'll just leave that as W. We know W equals mg. So W equals, that's pretty basic, it's 98.1. So now, let's say we were also given the angle, then we'd be able to find out what the force of friction was. So we'd get sine equals f of f over, actually, sorry, just rearranging it, we'd get 98.1 sine equals f of f. Right, does that make sense? So we could also do for finding the normal force, because, see, normally you'd think, all right, well, the normal force is equal, right, to the weight force. Well, not in this case, because there's an angle of incline here, it's actually going to be different. So what we'd have to do is, all right, we need to find this. Well, let's say this is the adjacent side of the triangle, right? N is the adjacent side of the triangle. So we want adjacent over, again, we know what the weight force is, so hypotenuse. So then what we do is N equals, we can just sub it in for this. So N equals 98.1 cosine theta. So that would be the normal force. So normal force is usually equivalent to the weight force, but not when we have an incline or the surface that the object is on. Remember, the normal force has to be perpendicular to that surface. So yes, the surface along here is the floor of this incline. Perpendicular would be straight that way. So I hope that makes sense. But yeah, that's how you would find your variables. That's how you can find the force of friction, or the normal force, whatever. Or if there was a force going this way, you would be able to find that as well. Okay. So now I'm going to clear just some space here. I'll leave that actually. Now I thought we'd get into some questions. I'm going to leave this one because this one's a bit trickier, and we're going to save that for last. I'm going to go into this one first. So the diagram shows the forces acting on a block resting on an inclined plane. Right, it's pretty similar to what we just did here. The angle is adjusted until the block is just at the point of sliding. R is the normal force, normal force, normal reaction. W is the weight of the block, and F is the maximum frictional force. Right, so it says the angle is adjusted until the block is at the point of sliding. So we're going to utilize dynamic friction here, or the maximum of static friction, right? Because once you exceed the maximum of static friction, it becomes dynamic. So it's asking for the maximum of static friction, maximum coefficient. Okay. So what is the maximum coefficient between the block and the plane? All right. So let's look at our equation here. So we're dealing with static friction. So we're going to use this one. So I'm just going to, don't have much space to write. Force of friction equals, that's a Greek letter. I can't remember what the name of it is exactly again, but that's the representation of coefficient of static friction. So what is the maximum? Right, okay, so we're just going to have to rearrange this equation, and we get the force of friction over R. Okay, well, now that we know what our equation is, we're going to use what we learned over here to find out what it is exactly we need in order to find the answer here. So the answers here are listed as angles. Well, that's interesting. So if they're listed as angles, we're going to be using kind of this looking formula here, right? So let's label this again. Right, this is R, and this is F, and this is the angle. Okay, so we need to find what type what do we want to use? Sine, cosine, or tan? Okay, so let's look at this. Right, the coefficient is equal to the force of friction over the reaction force, or the normal force. So where in this triangle is the force of friction? It's on the bottom here. So this is opposite to the angle, so opposite. And then over, which side is the R side? The R side is the adjacent side. So in order to find the coefficient of static friction, we would need to find the opposite side of this triangle over the adjacent side, or the force of friction over the reaction force, and that is opposite over adjacent. And which one of these utilizes opposite over adjacent? Tan. So our answer would look like this, right? And so we would circle C, and C is the correct answer. Okay, so now on to our last question. Just make some room here. This one's a bit trickier. This took me a while to figure out and understand, but we'll go through it together, and you should be able to catch on pretty quickly. So, a block of mass 1 kilogram rests on a trolley of mass 4 kilogram. The coefficient of dynamic friction between the block and the trolley is 0.3. Now, notice there's no units. That's because it's a ratio, and ratios do not have units. So, just quickly, rearranging this equation, it's R over F of F, and that's a ratio, so you would not assign a unit to a ratio. Anyway, a horizontal force of 5 newtons acts on the block, and the block slides over the trolley. What is the acceleration of the trolley? Okay, now this question is quite loaded with a lot of different components, but we're going to figure it out. So I'm going to start with a base formula that we know we're going to end up using, and that's F equals ma, right? Because we're trying to find the acceleration, we're going to start with F equals ma. Now, what is the acceleration of the trolley? What is the mass of the trolley? The trolley is 4 kilograms. So we know it's going to look like this, 4a. Okay, that makes sense. We're trying to find the acceleration of the trolley. Well, we're going to have to know what the mass of the trolley is, and it's 4 kilograms. So this is what our final, we're going to have to find what F is now. But we know this is what our equation is going to end up look like. Okay, so now we need to find, so we see the term coefficient of dynamic friction between the block and the trolley is 0.3. All right, so we know we're going to use this equation somehow. So why don't we write this equation out? Equals, I'm just going to write it in the 0.3 times the normal force times R. Now, what is R? Okay, so this is on a flat surface. The block is on a flat surface. We already know that this is going to be W, right? And so the normal force, well, perpendicular to this surface is just straight up, just like W, except the opposite direction, and R. We could literally get rid of this and put in W instead. They're exactly the same. But what we do need is to find W. So what is W? Well, we know W is going to be mass times acceleration, or mass times G. So mass of 1 kilogram. So let me just make some space. So mass times mass, which is 1, times G, which is, we're just going to call it 10. Okay, so this is what we've got so far. So F of F equals 0.3 times 1, that's just 0.3 times 10 equals 3. Okay, so now that we have that, all we have to do is plug that back into the formula. So, because the force we're talking about here in this case is the force of friction. So when we put this back into the equation, we get 3 equals 4a. Rearranging this, 3 over 4 equals a equals 0.75 meters per second squared, and that is what we get, and it is the right answer. Now, the reason this question is a bit difficult is because there are some components that will try to throw you off, such as the fact that there's a horizontal force of 5 newtons. Now, that might confuse you and you say, oh, where do I need to put this into the equation? What I did initially was I subtracted 3 from 5 because I thought that would be the net force, but no, that's not what you meant to do. The key part to this question is to know to use the frictional force for F in the equation F equals ma. So the reason we would use that is because when the block is pushed forward with a force of 5 newtons, there's going to be a frictional force in the opposite direction for the block, but a forward direction for the trolley. So it'll be in the same direction as the 5 Newton force. And because of this, it is in the same direction that the trolley will accelerate, and so that is the force we're dealing with. The force that is applied to the block is not at all related to the force that is put onto the trolley. And so since we're dealing with the acceleration of the trolley, we want to know the force that is being applied onto the trolley as well. And that's only through the frictional force. That's it for this video. I'm going to leave off here. I could have done some more questions, but I think this was the best way to go. This was a bit more complex, especially this question compared to our more recent topics. So if you do have any questions, don't be afraid to email me, and I will either make another video if there's enough content to cover, or just simply reply to you as soon as possible. Okay, thanks, leave a like, subscribe, and I'll see you guys in the next video. Till then.